Alright guys, so in this video we're going to look into some more applications of functions. We have a little word problem on here that I want to dive on into. I just so how we can utilize a little more so in some real world scenarios. So it says you work in the marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4. It says write the volume of the can as a function of the radius r. And then it says write the volume of the can as a function of the height h. Alright. Well, the thing we have to take into account is what's the goal? What does it mean to be a function of r? Well, it means when it is a function of the radius r, that means there can be no other variable inside of the volume function other than r. That's all we can have in this case. Same thing for part B. The volume of the can as a function of height h is just simply all we can have is the variable h in the volume function itself. Alright? And I've kind of given you a little bit of a hint down there at the bottom. And that goes to the ratio of the height to the radius being 4. Alright, the ratio of the height to the radius is 4 in this case. Well, why is that useful? Because this gives us a secondary solution, secondary equation in which it involves h and r, and it allows us to solve for either h or r depending on what we want. So we all agree, let's just say for instance an example like this. Alright, we know this is 4 over 1, so if I cross multiply it on over here, I have h equals 4r. So h actually equals 4r in this example. Okay, well what if I wanted to solve for r? Well, I'd go ahead and divide by 4, and so I know that r equals h over 4. Why is this useful to us? Because this is what r is, or h is in terms of r, and this is what r is in terms of h. And so we can utilize that in our two volume scenarios that we have. So let's take a look. And for part A, it says V of R. That's what it means. It wants to know the volume with respects to radius R. So I know that the volume is pi r squared h, but I cannot keep h in vol. Nope. What I have to do is now take what I know about h and go ahead and use that information. So pi r squared times 4r, or in the end this ends up being 4 pi r cubed. So that would be the volume with respects to r as a function of r. Now you can kind of probably guess at what's coming on up next for part B is that same kind of example. Is now for part B, let me go ahead and change some colors here. So for part B, we want V of h. So again, we know that it's pi r squared times h. But I can only have h in there. But I already know that r, as a function of h, is h over 4. Now I've got h only as my variable. And now I'm looking at h squared over 4 times pi. Alright? So hopefully that kind of, oh, I'm sorry, actually, hold on guys. Made a little mistake right here. I did not square it. Something didn't look right. H squared, hold on one sec. So let me back up. Hold on, that becomes, so we end up having h cubed over 16 times pi. Glad I caught that. Okay? So we're going to get h cubed over 16 times pi, because it was r squared. So careful on that. Don't make those mistakes either. Alright guys, so what I got for you on this next slide is if you'll do me a quick favor and give this one a shot on your own. Now it's a different type of example, alright, but again it's still a real world application of how to utilize functions themselves. So give this one a shot on your own, and we'll go over it first thing, and we're on to the next one.